Okay, in this video I'm going to talk to you about the design to lifecycle models. The first one of them is known as the design to schedule lifecycle. This model is similar to the stage release lifecycle model that you plan to develop the product in successive stages. The difference is that you don't necessarily know at the outset that you're ever going to make it to the last release. You might have 5 stages planned but only make it to the third stage because you have an immovable deadline. And that's what this figure right now is illustrating. This lifecycle model can be a viable strategy for ensuring that you have a product to release by a particular date. If you absolutely must have functioning software in time for trade show, or by year's end, or by some other immovable date, this strategy guarantees that you'll have something. This strategy is particularly useful for parts of the product that you don't want on the critical path. So, for example, when Windows was being made originally, they used to have all of the minor system functionality tools like WordPad, Paint, and the game called Hearts. Microsoft might use the design to schedule for those apps to keep them from delaying the overall Windows build, for example. One of the critical elements of this lifecycle model is that you must prioritize the features and plan your stages so that the early stages contain the highest priority features. You leave the lowest priority features for later. If the ship date arrives before you've completed all the stages, you don't want to have to leave out critical features because you've spent time implementing less critical ones. The primary disadvantage of this approach is that if you don't get through all of the stages, you'll have wasted time specifying, architecting, and designing features that you don't ship. If you hadn't wasted time on a lot of those incomplete features that you didn't ship, you would have had time to squeeze in like 1 or 2 more complex features. The decision about whether to use the design to schedule model comes down to mostly to a question of how much confidence you have in your scheduling ability. If you're highly confident that you can hit your schedule targets, this is an inefficient approach. If you're less confident, this approach just might, well, save you. A similar design to model to this is the design to cost, where instead of looking at a hard deadline of time, you're looking at a hard deadline of costs. That's the only difference. That brings me to the other main design to lifecycle model, which is called design to tools. This is a more radical approach that historically has only been used within, say, more time-sensitive environments. As tools have become more flexible and powerful, complete application frameworks, visual programming environments, full-featured database programming environments, the number of projects that can consider using design to tools has increased. The idea behind design to tools model is that you put a capability into your product only if it's directly supported by existing software tools. If it isn't supported, you just leave it out. By tools, I mean code and class libraries, code generators, rapid development languages, and other software tools that reduce the implementation time. As the figure suggests, the result of using this model is inevitably you won't be able to implement all the functionality that you ideally would like to include. But if you choose your tools carefully, you can implement most of the functionality that you'd like. When time is a constraint, you might actually be able to implement more total functionality than you would have been able to implement with, say, another approach. But it would be the functionality that the tools make easiest to implement, not the functionality ideally you would like. This model can be combined with other flexible lifecycle models. You might conduct an initial spiral to, say, identify the capabilities of existing software tools and identify the core requirements and determine if, say, the design tools approach is workable. You can use a design to tools approach to implement a throwaway prototype, prototyping only the capabilities that can be implemented easily with the tools. Then implement the real software using one of the other lifecycle models. You can also combine this model with, say, a stage delivery, evolutionary delivery, and the design to schedule. The design to tools model has a few main disadvantages. You lose a lot of control over your product. You might not be able to implement all the features that you want, and you might not be able to implement other features exactly the way you want. You become more dependent on the commercial software producers on both their product strategies and their financial stabilities. If you're writing small, mostly disposable programs, that might not be much of a problem. But if you're writing programs that you intend to support for a few years, each vendor whose products you use potentially becomes a weak link in the product chain. Okay, that's the end of design to tools. Tune in for the next video.